Hi, I'm Jay Pipes. I'm a principal open source engineer here on the EKS team at AWS, and really excited to tell you about a project that I've been working on for the last 3 to 4 months, along with a number of other engineers, and it's called AWS Controllers for Kubernetes, or ACK. So let's get started. To tell you a little bit about the value proposition of ACK, I'm just going to tell you a little bit of the story. Should be a fairly familiar story for some of you. So we've got Alice. She's a web developer, and she works for a department at her company and she's developed this Node.js application. She's building this application using modern application development processes and creating immutable Docker images of her application. And she's used the SQLite database for simple storage needs for her application. That's initially what her choice was, to use SQLite. And Alice is a huge Kubernetes fan, and so naturally she goes to deploy her application onto Kubernetes, and she uses the typical kubectl apply. She applies a deployment manifest, a service manifest, and probably an Ingress Nginx load balancer artifact. And everything's great. She's got her web application, her Node.js application up and running, and everything's working, but then she has a bunch of concurrent users trying to use the site all at once, and just because, frankly, predictably, SQLite falls over because it's not really designed for highly concurrent database access. So Alice decides, look, I need to set up a real database server for my application to use, not SQLite. And so Alice goes and Googles for a tutorial. How do I, set up Postgres, which she's heard is a quote real database server. How does she set one up on Kubernetes? And she sees a bunch of tutorials out there. Essentially, those tutorials boil down to running kubectl apply for a persistent volume claim. So she's got some sort of persistent disk storage for her database, a deployment manifest, and then the service to handle top-level networking for the database service. And Alice gets it all set up on Kubernetes, and she's relatively happy. But after a few weeks of running Postgres in production in Kubernetes, she realizes that, well, she's kind of becoming a DBA, and that's not really what Alice had in mind. So what is Alice to do? Well, she learns about Amazon's RDS service, which is an AWS managed service for relational databases. And she thinks, oh, this is perfect. Now I can set up an RDS database instance, and I no longer have to be the database administrator. This is perfect. But there's only one problem with that is, like I said, Alice is a huge Kubernetes user and a huge Kubernetes fan. And she's really disappointed that she's got to go into the AWS Console to manage her RDS database instance, both to create it and update it, etc. And that's not what Alice likes. Alice wants to use the Kubernetes API for managing all of the resources that are related to her application, including the database. Well, she didn't have to use the AWS Web Console. She could have used the AWS CLI tool, but then she would have to install that locally, this set of AWS Python tools. She could have used CloudFormation or Terraform, both of which are fine tools. But at the end of the day, both of those are not Kubernetes, and they would have required Alice learning sort of a whole different set of technologies and languages for setting up just her RDS database instance. And Alice really likes Kubernetes, and she's a big fan. But not really enough to be a database administrator. She doesn't want to actually administer and maintain Postgres on Kubernetes. She wants to use RDS, but she doesn't really want to leave her Kubernetes experience. So what can she do? Well, what if Alice could just simply kubectl apply a Kubernetes manifest that looks something like this, with a kind of DB instance and some attributes describing her RDS DB instance, and kubectl apply it, and magically she would get her RDS database instance set up and managed for her. Well, that's essentially what AWS Controllers for Kubernetes is. It's bridging the AWS Managed Service APIs with Kubernetes API experience. And well, it was solving Alice's problems, and let's see if it'll actually solve some of yours too. So let's take a look closer. So like I said, ACK, AWS Controllers for Kubernetes, it is a Kubernetes experience for AWS services. It's bringing the large universe of AWS managed services, of which there are many, 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 to the world of Kubernetes users. So for the AWS managed services, they expose through an ACK service controller a custom resource definition for top-level resources in their API. So for instance, the RDS API has DB instance, DB cluster, DB snapshot, etc. Those are top-level resources. An ACK service controller for RDS exposes Kubernetes custom resources of a kind equal to the DB instance or DB cluster or DB snapshot, depending on what is the AWS managed service behind the scenes. So like all controllers in the Kubernetes universe, Kubernetes stores the desired resource state for those resources in its etcd database storage, and custom controllers, of which ACK service controllers are, they read the desired resource state from the Kubernetes API server, and then each of those ACK service controllers communicates with the backend AWS Service API and handles the lifecycle of those AWS managed service resources. So Kubernetes is storing the desired resource state for those DB instances or S3 buckets or SNS topics or whatever they are. And the ACK service controller has a reconciliation loop that is constantly trying to make the actual state of that resource in the AWS Managed Service API match the desired state that's in Kubernetes. And this last point about no CloudFormation behind the scenes is important because ACK is actually has its roots in another project called AWS Service Operator. And the AWS Service Operator actually used CloudFormation behind the scenes. So when you created, say, an S3 bucket manifest and the AWS Service Operator did the needful behind the scenes, it would actually create a CloudFormation stack, which then created an S3 bucket. And we thought that was sort of a surprising user experience and kind of hid a lot of details behind CloudFormation. And we wanted to kind of get away from that. So AWS Controllers for Kubernetes, we're not using CloudFormation at all behind the scenes. We're just making direct calls to the individual APIs. So one of the big picture architectural design principles of ACK is that each AWS managed service has a separate ACK service controller. Now, originally we thought, well, maybe we'll just build one big binary that will be like the ACK controller. And you'll install this one ACK binary in your target Kubernetes cluster, and it would be responsible for communicating with S3 and SNS and SQS and RDS and all the other different AWS managed service APIs. Well, we considered that briefly and then thought the security surface area for the permission set associated with the IAM role that would be needed for such a single binary was entirely too broad for us to be comfortable with. And that's why we have structured things so each AWS managed service has a separate ACK service controller. And that way we can scope the permission set that the IAM role associated with that ACK service controller has to as fine-grained as we possibly can. Basically, only have permissions to manage the lifecycle of resources associated with a particular AWS API and not all sorts of APIs. With a single binary approach, we essentially have to have super user privileges for the IAM role associated with the single ACK controller binary. We thought that was too broad. You can install ACK service controllers individually using Helm or static manifests or customize. We also have a helper script so that you can install multiple ACK service controllers really easily. We also have a fully code-generated controller implementation. So we realized early on that there's just no way that we were going to be able to hand build 160, 180 plus different ACK service controllers for each of the AWS managed services. So we had to rely on generating code for everything, including obviously the Kubernetes API types, the CRDs, as well as the implementation of the controller itself. We're consulting with those AWS service teams, however, to make sure that the code that is generated for an ACK service controller is calling the backend API in a semantically and behaviorally correct way. So for instance, we're working with the Elasticache team and the API gateway team, et cetera, to make sure that the ACK service controllers for those particular services are behaving in the most accurate way possible. Finally, it's important to point out that ACK is not specific to EKS. So you can install ACK service controllers in any Kubernetes target cluster. It's not just the Kubernetes managed control plane flavor that is EKS. I mentioned that we're using a code generation strategy for pretty much everything within ACK. We have this sort of multiple phase approach to code generation where we read the models or the sort of schema documents of the individual service APIs from the AWS SDK Go source repository. We figure out which of these top level resources that should be the custom resource definitions, right, the CRDs. Then we create those Kubernetes API type definitions. We generate a resource manager for each of those custom resource definitions. And then we generate sort of a linkage between the AWS SDK Go of that particular managed service and the common ACK runtime. And then finally, we generate a bunch of configuration and build files. So it's sort of like a little overview of this multi-phase code generation as we sort of build up the individual service controllers within ACK. One important topic that kind of touched on earlier with regard to our decision to use a single ACK service controller per AWS managed service is authorization and access control. Now, because ACK is bridging the divide between Kubernetes world and AWS world, there are two role-based access control systems in place at any given time. Kubernetes native RBAC is always in place for custom resources themselves. So a Kubernetes cluster administrator will be able to configure Alice as a Kubernetes user to be able to create, read, and write custom resources of kind, say, RDS DB instance, but not create, say, S3 buckets. So the Kubernetes RBAC system is in place for custom resources in that way. But the entity that is actually communicating with the AWS APIs is the ACK service controller for that managed service API. And the role-based access control that is in place for that entity is IAM, right? The AWS Identity and Access Management service. And there is an IAM role associated with the service account that is running the ACK service controller pod. And the permission set associated with that role is what dictates what the service controller can do in a target account for a specific set of APIs and API actions. Each ACK service controller is in its own deployment. So you can supply the deployment which has the template spec, set of environment variables for the AWS access credentials, including a temporary role ARN if you wanted to use, say, an STS temporary access credentials. And then you can use IAM roles for service accounts to automate this entire process. One thing that we did notice is that it's probably a suboptimal user experience to have to install ACK service controllers in lots of different target Kubernetes clusters. So if you wanted to say manage S3 buckets in account A and manage RDS database instances in account B, you will need to install an ACK service controller in different Kubernetes clusters that are associated with a specific AWS account ID. We thought that that's not really a great user experience, and so we're building in the ability to have the ACK service controller installed in one Kubernetes cluster, be able to manage resources in multiple AWS accounts. And the way that we're doing this is to have a namespace, a Kubernetes namespace, annotated with an AWS account ID to which all custom resources within that namespace will be associated. So the application developer will call kubectl apply with a custom resource. That'll be in a specific namespace. The ACK controller will look up the role ARN, AWS resource name, and AWS account ID from the namespace annotations, and then call STS assume role to pivot the client within the ACK service controller so that it can then manage resources in that separate target account. And in this way, we can allow the ACK service controller to manage resources in multiple AWS accounts and not have to be installed in multiple pods or multiple Kubernetes clusters. So what about secret stuff? One thing that Alice noticed when she called the create DB instance call is that the master user password is sent in plain text. Clearly, this isn't best practice for Kubernetes land, and so the way that we're handling this is identifying certain fields within a custom resource definition that contain plain text secrets, and we're replacing those with secret reference objects so that the Alice will be able to set up a DB secrets secret in Kubernetes and a key within that secret with her master user password, and then simply reference that secret value from her custom resource, her DB instance. So other things that I'm pretty excited about, we are standardizing the way that AWS tags are represented for all ACK custom resources. Right now, each of the APIs has slightly infuriatingly different representation for AWS tags, and we're going to be standardizing that so that Kubernetes users can just apply an AWS tag to any resource that's managed by ACK in the same consistent fashion. Secondly, we're going to have a set of tags, AWS tags, that are in namespaces annotation that will always be set on custom resources that ACK service controller manages. So if you, for instance, wanted all DB instance custom resources to have an AWS tag of foo, you would be able to annotate the namespace, and the ACK service controller for RDS would ensure that an AWS tag of foo was always associated with all DB instances. Finally, we'll have support for a common rate limiting and throttling library, as well as adopting resources that are created out of band from ACK. So let's say you have an S3 bucket that's already existing, and you essentially want to tell ACK's service controller for S3, hey, you start managing the lifecycle of this particular bucket. We'll be supporting that use case as well. So right now we have developer previews for these APIs, S3, SNS, SQS, ECR, DynamoDB, and API Gateway v2. And we're trying to fast follow within a month or so these service controllers for RDS, for Elasticache, CloudFront, some objects, some of the sort of primary networking objects within EC2, and also the EKS API itself. ACK is a 100% open source, 100% transparent community project. We are very much interested in your contributions, in your feedback, and your suggestions, bug reports, and basically if you'd just like to try ACK service controllers out and give us your honest and honest feedback, we'd love it. Thank you very much.